In this video, we'll explain why e is the best base for logarithm function and exponential function when you want to do calculus. So first remember that there's not one exponential function, there are plenty of them. Because for each value of the base a, you get one exponential function. So 2 to the x, 3 to the x, 1/2 to the x, 1/3 to the x are all called exponential functions. Now for each and every of these exponential function, we have defined a logarithm function such that they're inverse of each other. That means down now we have an infinite number of exponential function together with an infinite number of logarithm function, and we would like to know which one works best for us. Well, let's try to see what their derivatives are. And to do this, we want to use the formulas we have. So we know a formula for the derivative of ln, which is logarithm base e. And we also know that it's possible to rewrite the logarithm in any base in terms of another base. So that means if I want to rewrite my functions before taking the derivative, I could write, using the change of base formula, that's ln of x over ln of a. I am going to rewrite it once more to make it very clear that this is a constant. 1 on ln of a is a constant because the variable is x, not a, times a function. And now that it's written this way, that makes it easy because I know if I have a constant times a function, the derivative is the constant times the derivative of a function. So let me summarize what we have. This shows that if you start with log of any base a, you will anyway get the natural log popping up. Another thing you could say is, hey, I don't want this ugly constant in my formula. Well, one way to get rid of that would be if your ln of a was 1, right? Assume ln of a is 1, then your derivative would just become 1 times 1 on x, and it would be 1 on x. That's much nicer, right? And for which value do we have ln of a is equal to 1? Well, exactly when a is equal to e. Let's now try the derivative of a to the x. And again, in our list of formulas, there is none for this one. So what we're going to do is rewrite the function before we take its derivative. And we know that if we apply exponential and logarithm in succession, we're doing nothing because they're inverse of each other. So exponential of ln of something, as long as the something is positive, will always be the something itself. So that's exactly what I've done, where what goes in this box is a to the x. Now the log laws tell us that we can actually drop the exponent in front of the logarithm, and we get x times ln of a. And now we can use the chain rule. If y is equal to x times ln of a, then y is exponential of something, where the something is the constant ln of a times x. So the derivative will be dy du times du dx. dy du, since y is exponential of u, will simply be exponential of u. And du dx, since u is a constant times x, will be the constant times 1. Let's summarize what we have. We proved that the derivative with respect to x of a to the x is y, is just ln of a, I'll put it at the front, I like my constant at the front, times exponential of u, but exponential of u was y, and y was really a to the x. So just like in the previous example, you'll start with a base equal to a, and what pops up very naturally in your calculation is ln of a, meaning that now the base is e in this logarithm. And again, if you pick any base a, you will get this constant. And if you don't want an ugly constant there, you could have the same choice, picking ln of a is equal to 1, and if you do so, that means a is equal to e. So you will get a is equal to e, And for this specific value, something almost magic happens. If a is equal to e, then the derivative of the function will be the function itself, because this term will be equal to 1. This is really what makes exponential and ln special, and why when we do calculus, we usually choose e as our favorite base. Thank you for watching this video. I hope you liked it.